So quite common with this question is to actually confuse what certain values stand for. Okay, so up here, s is actually an unknown, and we want to find the value of s in the first question. We're given t there, okay, because it says t is equal to 0 is the beginning of 2010. T is equal to 0 at the beginning of 2010. And we know in this question we're dealing about the beginning of 2010. So t is equal to 0. So what's left? Well, what do we think 1,100,000 could be? It's P of t, the actual population of Sapphire City. Okay, so P of t is equal to 1,100,000. So now it's a case of going and actually finding the unknown s. So 1,100,000 is equal to s e to the 0.1 times 0 by 10 to the 6. Okay, now we actually know what e is. E is a number, remember? We know what this is. So we can deal with all that together. And also, what's quite nice is that it's e to the power of 0. And we actually know what e to the power of 0 is. Anything to the power of 0 is 1. We actually already dealt with it as well a few minutes ago in the previous part of this paper. So 1 by 10 to the power of 6. We want to find s on its own. So this is like s multiplied by this number here. So it's the opposite of multiplication. Division. One by 10 to the 6. And we find that s is equal to 1.1. Lovely 10-mark question. 0, 4, 10. Really nice. Find the predicted population of Sapphire City at the beginning of 2015. So, really important, now that we know a new piece of information, to write down that P of t is equal to 1.1 times e 0.1 to the t, and then it is multiplied by 10 to the 6. Okay, so you can leave that out in a bracket out front if you want. That's what the s was. Now we know what t is. Well, at the beginning of 2010, e was 0. So that means the beginning of 2015, t. So at the beginning of 2010, t is 0. And at the beginning of 2015, t is going to be 5. So it's just p of 5, 1.1. E 0.1 times 5, 10 to the 6, P of 5, 1.1, E 0.5 by 10 to the 6. Multiply all that out, P of 5, and you get 1813593. And let's just check, does that make sense? It's nearly 2 million when t is 5, and it was nearly just over 1 million when t is 0. So the population has increased by about 700,000. Find the predicted change in the population in Sapphire City during 2015. So beginning versus end. So beginning in 2015, t is equal to 5. The end of 2015, t is going to be 6. So we know what the population was. So it's p of 6 minus p of 5. So we need to go and find p of 6, which is 1.1 e to the 0.1 times 6 by 10 to the 6. Minus 1813593. Put that all into your calculator and you will end up with 190737. Okay, might be a little bit easier if you go and actually calculate this section first, but there's no need to if you type it in correctly. Okay, next question. Or well, maybe before I go on to the next question, it might be useful to actually go in 0, 4, 10. It's a nice another 10 mark question. And 0, 3, 4, 5. Okay, so both relatively easy questions, 25 marks for the first 3 parts there, so yeah, very, very quick to actually fly through. There, so next question. The predicted population in Avalon at the beginning of 2011 is 3,709,795 people. Write down and solve an equation in K to show that, okay, K is that. So we know, well, it was at the beginning of 2011, so that's T is 1. We know the population. Now, what was the actual function for that? I can actually take that whole thing down, can't I? Because it's going to be useful. So we know the population, which is Q of T now, is this number. We know T is 1. And we need to go and find K. So 3709795 is equal to 3.9 E K, and this is a 1 here. I'm not going to write it in because K by 1 is just 1, by 10 to the 6. Now, this is an equation with 1 unknown, so we should be confident that we should be able to solve it. Okay. So, on the right hand side, it's kind of useful to know that the order of multiplication here on the right hand side doesn't matter. So I could write it as this, and then divide to try and get e to the k on its own. Now remember, we know what e is. That's not the big bad scary part. We need to find the k. So it's this multiplied by e to the k. So how do I get rid of it? Well, what's the opposite of multiplication? Division. 3709795 divided by 3.9 by 10 to the 6 is equal to e to the k. Okay, so now what do we need to go and find? We need to go and find our find our k. And this should look familiar. We don't know an exponent. When we don't know an exponent, you should go to page 21 of your log tables. 21, not 1, page 21 of your log tables. And use our rule on the top right hand corner. A to the x is equal to y. Log to the base a of y is equal to x. So, looking at it, we know our y. Okay, it's what's on its own. And our a, which is e. So it's going to be log to the base a, which is our e, of y. So 3709795 all over 3.9 by 10 to the 6 is equal to k. K is equal to, type it all into your calculator, and you should get minus 0.5 if you've done it right. So pretty nice. And just a quick reminder that when you're actually putting it into your calculator, it's useful to know that log to the base e, a little shortcut, you can just type ln and it works. And another like really heavily marked question, 0, 5, 10, 15. You'd be very, very happy with that. Okay, already there's quite a lot of marks gone for the start of this question. Find the year during which the population in both cities equals to each other. When do they equal each other? We'll go back to maybe it was second year that you started doing simultaneous equations. What were you doing with simultaneous equations? You're finding the point of intersection of two lines or two functions. Okay. Another way of thinking of it was you're letting the two functions equal to each other and solving them. So we're finding the point of intersection between p of t and q of t. And we can do that by letting them equal to each other. So remember, what was p of t? 1.1 is equal to 0.1 to the t by 10 to the 6, which was equal to 3.9 e minus 0.05 t by 10 to the 6. Fortunately on both sides, so what we're looking for is t, and on both sides we have the 10 to the 6. So on both sides we can divide both sides by 10 to the 6 and just have 1.1 e 0.1 to the t is equal to 3.9 e to the minus 0.05 t. Really useful now to have your page 21 open on your log tables because, well, we'll look at some indices rules in a second. So you want to try and get t on its own. Okay, so the way we can start going about that is dividing both sides by 1.1. So we'll have e is equal to, or e to the 0.1 t is equal to 3.9 e to the minus 0.05 t all over 1.1. And we want to get the t on the other side as well, onto the left hand side. So if we divide both sides by e to the 0.05, e to the 0.1 t divided by e to the minus 0.05 t is equal to 3.9, 1.1. Now this section, if you go to your log tables, page 21, and look at the second rule of indices, the bases are the same here, and it's division. So we can actually subtract, I'm just going to bring this up here, the powers. So we'll have e 0.1 t minus, so it'll be a plus 0.05 t is equal to 39 over 11, which is the same as 3.9 over 1.1. This will be e to the 0.15 t is equal to 3.9 over 1.1. Now, it's exactly the same as the previous question. We don't know the index. We didn't know the k up here. We don't know the t down here, which is the index. So again, page 21, if we have in the top right hand corner a to the x is equal to y log to the base a of y is equal to x. So what's my a? A is equal to e. 0.15 is equal to x. So log to the base a of 3 not to the base a, to the base e, the base e of 3.9 over 11, 1.1 even, log to the base e of 3.9 over 1.1 is equal to 0.15 t. Divide both sides by 0.15. Log to the base e 3.9 over 1.1 is equal to t. And this was all over 0.15, wasn't it? So t then is equal to 8.44. But what year is that? That was the year 2018. During the year 2018, their populations would be the same. So we want to find the average population, average being a big hint here. So we're going to use the average value of a function formula, which is 1 over b minus a, the integral between b and a, q of t dt. Now a is equal to 0, because it's time 0 is where we're starting at, and b is equal to 15, because we're ending when time is 15, or the start of the 15th year. So it's 1 over 15 minus 0 is still 1 over 15, 15, 0, and then input the function 3.9 e to the minus 0.05 t by 10 to the 6 dt. Now how to integrate the e to the power of? Well, we touched on it earlier on, that it's 1 over the derivative of the power. So there's the derivative, or 1 over the derivative of the power. Here's the original by 10 to the 6, and we're doing that between 15 and 0. So now we need to go and sub in 15 and then subtract when we sub in the 0. I might just put in a little bracket to distinguish between 3.9, 1 over minus 0.05 by e to the minus 0.05 by 15 by 10 to the 6. And then we're going to subtract. If we'd put in a 0, so again, 3.9 by 1 over minus 0.05, 0.05 by 0 by 10 to the 6. Well, I've just lost a little bit, but hopefully I can write it in. 15, 15, 0, 1 over 15, 1 over 15. And we're back to being what we had, I think. Yeah. Okay, multiply all of that out, and you end up with 2.7436 by 10 to the 6, which is 2743694. So again, average value of a function, average, you need to know that formula right there, and it's not a very important question, or part of the question, 0, 3, 4, 5, so not massively heavily weighted with the marks. And most important part of it is knowing how to integrate e to the power of something. Okay, so it's 1 over the derivative of the power, and then you continue to write down what you had. How to integrate it, 1 over the derivative of the power. Use the function q of t to predict the rate of change of the population of Avalon at the beginning. So that would be t is equal to 8. Okay, and rate of change, well, what does rate of change mean? Well, that's differentiation, okay, the derivative. So q of t. Well, how do we get the derivative of that? Okay, well, we bring down the derivative of the power. So minus 0.05, 3.9 e to the minus 0.05 t by 10 to the 6. Now we want to find that when we have t is 8. Minus 0.05, 3.9, 0.5 by 8 by 10 to the 6. Okay, so again, how do you, well, we'll multiply it out and then I'll talk about it in a second. Minus 130712. So the population is decreasing. because of the negative rate of change. Okay, so it's decreasing by that much. Again, how do you differentiate this? Okay, it's not just bring down the coefficient. The phrase is to bring down the derivative of the power. Okay, bring down the derivative of the power, because if you had like a cubed there, then you'd be doing the wrong thing. If you just brought down the coefficient, you must bring down the derivative of the power. And that question, again, was 0, 3, 4, 5. So they really front-loaded this question quite heavily. In general, the question was pretty nice though, the whole question.